There is something on Mars that even NASA doesn't fully trust. When we look at Mars from Earth, it seems quiet, distant, almost peaceful. A cold, red desert floating silently in space. Scientists call it our backup planet. Billionaires dream of building cities there. Space agencies talk about human colonies as if it's just a matter of time. But what if I told you that beneath all the excitement, there's one terrifying problem that keeps even NASA awake at night? This isn't about aliens. It's not about monsters hiding underground. It's something far more real and far more dangerous. Something invisible, something powerful, something that could silently destroy every astronaut who dares to step foot on the red planet. And the worst part? We can't stop it. Before we understand why this one thing is so frightening, we need to go back and understand why Mars became humanity's biggest hope in the first place. For decades, scientists have warned us that Earth is changing. Glaciers are melting, oceans are rising, wildfires burn longer, summers grow hotter every year. Even if we slow climate change, some damage cannot be undone. And then there are threats we don't control at all. A deadly global pandemic, a nuclear war, a massive asteroid impact. History tells us one simple truth: no species rules forever. Dinosaurs once dominated this planet. They were powerful, they were unstoppable, until one day they weren't. That's why scientists began looking for a second home, somewhere close enough to reach but stable enough to survive on. Mars became the obvious choice. It has seasons, it has polar ice caps, it has mountains, valleys, even ancient riverbeds. A day on Mars, called a sol, is just 40 minutes longer than an Earth day. At first glance, it almost feels familiar. But Mars is not Earth. Its atmosphere is thin, about 1% as thick as ours. Almost all of it is carbon dioxide. Oxygen? Barely there. Liquid water? Gone. Temperatures can drop so low at night that exposed skin would freeze in seconds. Still, none of that stopped us. NASA created machines to produce oxygen from carbon dioxide. Engineers designed underground habitats to protect humans from extreme cold. Scientists developed technology to extract frozen water from Martian soil. Greenhouses could grow food in sealed environments. Piece by piece, problem by problem, humanity found solutions. It started to feel like Mars was simply a hard challenge, not an impossible one. But here's the twist. There's one problem we cannot fix with shelters. We cannot drill through it. We cannot build walls against it. And it doesn't announce itself with noise or warning. It's radiation. Cosmic radiation. The silent killer of Mars. On Earth, we are protected by something we rarely think about, our magnetic field. This invisible shield surrounds our planet like armor. When deadly solar radiation and cosmic rays travel through space, Earth's magnetic field deflects most of it away. Our thick atmosphere does the rest. It's the reason we can walk outside safely every day. Mars doesn't have that protection. Billions of years ago, Mars likely had its own magnetic field, but something happened deep inside its core. The protective shield disappeared. Over time, the solar wind stripped away most of its atmosphere. What remained was a thin, fragile shell. And now, Mars is exposed. Every single day, powerful radiation from the sun slams directly into its surface. Cosmic rays from deep space pass through almost nothing before hitting the ground. NASA's Curiosity rover measured radiation levels on Mars. What they found was alarming. An astronaut spending 1 year on Mars would be exposed to radiation levels equivalent to hundreds of chest X-rays. Some estimates suggest a round-trip mission to Mars could expose astronauts to radiation near or even beyond NASA's career safety limits. But numbers don't fully explain the fear. Radiation doesn't just cause sunburn. It damages DNA. It increases cancer risk. It can harm the central nervous system. Some studies suggest it could even affect memory, decision-making, and emotional stability. Imagine being millions of miles from Earth, inside a small habitat, knowing invisible particles are passing through your body every second. You can't see it, you can't feel it, but it's there, constant, relentless. And it's not just the surface that's dangerous, the journey itself is worse. To reach Mars, astronauts would spend about 6 to 7 months traveling through deep space. During that time, they would be completely exposed to cosmic radiation. No magnetic shield, no thick atmosphere, just a thin spacecraft wall between them and the universe. What nobody expected was how unpredictable solar storms could be. The sun doesn't shine quietly all the time. Sometimes it explodes. Solar flares and coronal mass ejections can blast enormous amounts of radiation into space. On Earth, we see beautiful auroras. Power grids might flicker. Satellites might temporarily fail. On Mars, it's different. A powerful solar storm hitting astronauts without enough shielding could be deadly. In 2003, during the Halloween solar storms, radiation levels in space spiked dramatically. If astronauts had been traveling to Mars during that period, they could have received a dangerous dose in just hours. NASA knows this. Engineers are working on radiation shields, water-based barriers, even ideas for using Martian soil as protective cover. Some propose building habitats underground or inside lava tubes. But here's the uncomfortable truth. No solution is perfect. Heavy shielding adds massive weight to spacecraft. More weight means more fuel. More fuel means higher cost and engineering complexity. Underground habitats require heavy machinery and time to build. And during the first missions, astronauts won't have the luxury of massive cities or deep tunnels. They will arrive exposed. There's another layer to this fear that most people don't talk about. Radiation doesn't just affect the body, it may affect the mind. Some animal studies show that prolonged exposure to cosmic radiation can damage brain cells and impact cognitive function. For astronauts making life-or-death decisions millions of miles from Earth, even slight mental impairment could be catastrophic. Imagine this, a small crew living in isolation, communication delays of up to 20 minutes each way, no quick rescue, no immediate help, and all the while, radiation silently increasing their risk of illness. This isn't science fiction, it's physics. And even NASA admits radiation is one of the biggest obstacles to sending humans to Mars safely. But the story doesn't end there.
Because radiation may have already shaped Mars into the lifeless world we see today. Scientists believe that when Mars lost its magnetic field, solar radiation gradually stripped away its atmosphere. Water evaporated, rivers dried. The planet transformed from a potentially habitable world into a frozen desert. In a way, radiation didn't just threaten life on Mars, it may have destroyed it. And now we're planning to go there without fully solving the same problem. That's the irony. We dream of turning Mars into a second Earth, but Earth is safe because of protections Mars no longer has. Some researchers have proposed radical ideas like creating an artificial magnetic shield for Mars. One concept suggests placing a massive magnetic generator in space between Mars and the Sun. In theory, it could deflect solar wind and slowly allow the atmosphere to rebuild. It sounds like science fiction, but so did landing on the moon once. Still, even if we build shields, dig underground cities, and create protective habitats, radiation will always be part of the equation. It's not a temporary storm. It's not a seasonal dust cloud. It's constant. And that's what makes it terrifying. Unlike dramatic disasters, radiation doesn't create explosions or loud destruction. It works quietly, slowly, over time. An astronaut could complete their mission successfully, return to Earth as a hero, and only years later discover the cost. Cancer, neurological damage, health complications that no one can undo. That emotional weight is heavy. These astronauts aren't just explorers, they're sons, daughters, parents, partners. They will carry not only scientific equipment, but the hopes of humanity.
and possibly invisible damage. So why go at all? Why risk it? Because exploration has always required courage. When sailors first crossed unknown oceans, many never returned. When pilots first tested new aircraft, they understood the danger. When astronauts first launched into space, they knew something could go wrong. Progress has never been comfortable, but it has always been human. Mars represents more than survival. It represents curiosity, the refusal to stand still, the belief that we are meant to explore beyond our limits. Yet we must respect what we face. Radiation is not an enemy we can defeat with bravery alone. It requires innovation, patience, and honesty about the risks. The red planet may become our second home one day. Cities might rise beneath its surface. Children might one day look up at a smaller sun from Martian soil. Humanity could become a multi-planet species. But that future depends on solving the one thing even NASA fears, the invisible storm of the universe. Because Mars is not just a distant world waiting to be claimed. It is a harsh reminder of what happens when a planet loses its protection. And as we prepare to step onto its surface, we must remember space does not forgive mistakes. The dream of Mars is powerful, but so is the danger. And somewhere beneath that quiet red sky, radiation continues to fall silently, endlessly, waiting for the first humans to arrive. The question is not whether we can reach Mars. We can. The real question is, can we survive it?